Hello everybody! Today I'm going to be testing a myth, and that is the myth that says that you have to lap the plane bottom with the plane completely assembled. That means the frog is inserted and lever cap is locked down. And my reason for testing this myth is I don't believe it. I'll be testing the myth with two planes that came straight off my pile. The first one is a Stanley Bailey number 5, and the second one is a Bedrock number 605. Both of these old girls are in excellent untouched condition. Look at that. I do a lot of plane restorations, but I want everybody to know up front that I am not an expert at lapping. And I don't think there's any one right or wrong way of doing it. And I think that in general, for most of the work that we do, that lapping is overrated. And by that I mean I don't think the bottom of a plane has to be 100% flat all the way across the bottom. I'm going to use this old Stanley 20.5 circular plane to demonstrate what I mean by that. By adjusting the sole of this plane, you can plane both convex and concave surfaces. And with that said, I think we could all agree it doesn't take a rocket scientist to figure out that if your bench planes have a convex or concave bottom to the plane, you're not going to be able to plane a flat surface. And if we accept that as being true, then I'm going to take it to the next step. What I'm saying here by drawing those black lines on the bottom of this plane is if they were the only 2 points right there just ahead of the throat and anywhere after the throat, if those are the only places that they touch the wood that you're working on, they would be flat. You could wipe out everything before and after that and it wouldn't make a difference as long as it's not touching the wood. So looking at that from the side, what you see where I drew the black, just picture that metal being removed. And on the bottom where I drew the black, that's the only part that touches the wood. I could do that and this plane would plane flat, but what I've done then is taken a 14-inch jack plane and made it into a 6-inch long plane like a number 2. And of course that totally defeats the purpose of having the different length planes. So you want the touch points to be further out. So that means in order to take full advantage of the length of my plane, I need 3 touch points. I've redrawn them, one towards the toe, one towards the heel. You'll notice I didn't go all the way to the toe and I didn't go all the way to the heel because there's a reason for that. That area in front of the line there and behind the line here is normally feathered in. I've drawn an exaggerated line there on the toe and on the heel to show you what I mean by that, by feathered in. It is nowhere near as noticeable as that, and it's barely perceivable with the naked eye when you do it. So now with my 3 touch points, I've drawn some black lines on the side of the plane. That's where you could machine that metal away, take out 1/8 of an inch all the way across there. The toe immediately in front of the throat, and the heel would be the only place touching the wood, and it would plane perfectly flat boards. The problem, however, is you've got a convex area ahead of the throat, between the throat and the toe, and you've got another convex area between the throat and the heel. So that means unless you're an extremely skilled craftsman, what you're going to have then is a circular plane, because as your plane comes on and off the end of the board that you're lapping, you're not going to be able to keep it level. So in order to successfully joint a long board, you have to have more than 3 contact points. And that's what I mean by when I said you don't have to have a perfectly flat sole to the plane. And that brings me to the myth that says if you don't have the plane completely assembled, the bottom will not be lapped flat. The reason for that is that the frog screws and the lever cap are going to put stress on the bottom of the plane that's going to make it flex. And the whole reason for this video is because I don't believe that. In order to test this myth, we have to understand where and how forces are applied. And that's going to start with how the frog is seated into the bottom. On this bedrock, you can see is quite simple. It's a machine flat surface, straightforward. On the Bailey plane, what it does there is it puts all the pressure here and here. So if you look at the frog over here, it's this surface machine right here and this leading edge surface right here that's going to set on those 2 machine points on the bottom. The bedrock frog, the entire bottom surface is machined to fit perfectly flat on the bottom of the plane. The bedrock frog is secured to the bottom with 2 pins and 2 bolts. The very tips of those bolts right here fit into that little hole right there on the pin. When the taper point of that bolt goes into the hole of the pin, it pulls the pin down, tightens the frog up against the base of the plane. So my theory is if that machine surface is proper on the bottom and the frog, when you tighten those two together, it shouldn't put any flex anywhere on the bottom of the plane. And I think the same must be true for the Bailey plane frog design that uses two screws to hold it in place. Stanley has designed this base so that the screw is towards the back of the frog where the metal is the thickest. I doubt that it's going to flex. The next possible contributor to flexing the sole is the lever cap. The lever cap goes underneath the cap screw, and when you lock the lever, it secures the iron and the iron cap firmly to the frog. Just like this. The lever on the lever cap has a cam. As that lever is locked into the down position, you can see the cam pushes that lever cap spring open. And there's the full open. And there it is again in the unlocked position with the spring closed up. The lever on the lever cap is really a lever. What it's doing is making leverage, and it's between where the cam is, the cap pin, and then all the force is applied downward right here to lock the leading edge of that iron in place up against the frog. So it's kind of like an Oreo cookie. You got the outer cookie above and below, which is your lever cap and the frog, and in the middle is that delicious tasting filling, which is your iron and your cap iron. They are sandwiched in between and locked tight. So the assumption is there's a downward pressure exerted right here. When this locks in place, that's going to cause the leading edge of your frog to flex. That's going to transition through to the bottom of your plane, this surface right here, which is below the leading edge of the frog, and cause that to flex. And that brings me back to why I don't believe that the bottom of this plane flexes. I have seen far too many planes where right here and right here there'll be cracks coming from the back of the throat, and those cracks are caused when it does flex. I believe that a cracked throat is attributed to improper frog adjustment. Both the Bedrock and the Bailey designs, they have another machine surface here that I haven't pointed out yet. Right here at the leading edge, it's tapered different than where the frog itself sits. That's where the iron passes through. It's the angle of the iron to go through. The iron is not meant to rest on this section right here. If you got your frog back too far, your iron will rest right here, and all the forces of planing and the flex that you can have in your iron possibly will push down on that little surface right there, and it's going to crack your throat. If I could cut away the sides of the plane, you could see it better, so I'm doing it with this picture right here. Here's the frog screw that's locking the frog down to the bottom of the plane. There's your cap screw that's pulling your lever cap and sandwiching your iron together. There's the iron coming down through, and that little machine surface is right here, and there's the opening of the throat. The iron should not be resting on that little tiny machine surface right there. Look how thin that metal is. If there is any flex at all in that iron, or if your frog is loose, you're going to split your throat. And the last possible contributors to flexing the sole of the plane, I would say, be the knob and the tote. Crank those screws down really hard, maybe they could do it. I removed the rust from the bottoms using my homemade scraper and 150 grit sandpaper on a sanding block. There they are, ready to test. But I was very disappointed to see there it is, a giant crack at the back side of the throat. So what I did was I pulled out another bottom. It has a beautiful hang hole just like the other one, but what it doesn't have is cracks behind the throat. So now we're ready to go ahead and test the lapping and see if it makes a difference. I've marked both bottoms with an indelible ink marker to see if they're flat when I put them on the lapping station. My lapping station is a long piece of marble. I can attach 4 sheets of 150 grit paper to it. I like 150. You can use any grit that you want. First up is the Bedrock. I'm going to give it a few passes. Even pressure down. And see what we've got. As you can see, this plain bottom is not flat. Wherever the lines are gone and wherever the lines remain, it should all be the same. Now it's the same test on the number 5. That one looks a lot better. And while it is better, it is not flat. But the important part is, if you look up the center, I mean from almost end to end, it's wiped the line off. So that's not too bad. I'm going to continue working on both of these until I've lapped the lines off. Lapping the bottoms by themselves allows me to put both hands on them like this. I can stand over top of it and put even pressure down and work it back and forth, just like you see here. Occasionally I flip it end to end and repeat the process, putting even down pressure on the bottom. I couldn't do that if I was holding the handle. And after about 3 minutes worth of work on the number 5, this is what you see. And I think in general there's no reason to lap this down anymore. This is what it should look like. There are a lot of people that believe the toe, the heel, and the sides should be just like what you see it right here. And after about 5 minutes of lapping on the bedrock bottom, I'm going to call that quits. Now it's obvious where there's not perfect flat right there, and just like on the number 5, the sides are a little bit of marker showing, and there's the toe just like what it should be. You could continue lapping to remove this, but I don't think it's worth the effort. The difference there is going to measure in the thousandths of the inch. You got a nice long flat straight run. This should be a good plane just like it is. I finished lapping both of these planes by lifting up on the heel to hit the leading edge of the toe, lifting up on the toe to hit the back side of the heel, and then slightly tilting it to the left side and slightly tilting it to the right side so I could get the entire bottom of the plane. And now I've got what I consider some finely tuned bottoms. At this point you could go to finer grit papers, make them look prettier. Typically what I do is just go over it with 1000 grit with a hand sanding block. And now that I'm confident that these bottoms are flat, I'm going to test them one more time. First up is the number 5. I'm going to give it a few passes back and forth. And just like it should, it's cleaning it all off right up the center. And now it's on to the 605 to see what this bottom looks like. And that little bit of lapping confirms that both of these bottoms are in fact flat. No surprises, the toe and the edges look exactly like we thought they'd be. So to complete this test, I put on fresh 150 grit paper, redrew the marker lines, and I put both planes back together, and the irons are fully retracted. And now comes the moment of truth. The number 5 is first. 5 passes. Next is the 605. 5 passes. And now you need to imagine a drum roll, because here's the results. Exactly what I thought it would be. It is exactly the same as what it was before I assembled the plane. There is absolutely no difference. Well, there was one difference. It was not as easy to do the lapping with the thing assembled. I felt like I had more control when the tote and knob were not on the plane. But it's clear to see that in the end it did not make a difference. It is definitely safe to say that the evidence has showed us that this myth is busted. Well, I hope you enjoyed the video. I don't know what's next off the pile. We're going to find out later, because right now it's time for supper. Bye.